This nomenclature practice sheet 4. This is the last one of the nomenclature practice sheets I've given you, and I'm going to give you, by now on this sheet, you shouldn't need polyatomic ions. Paper I gave you guys, you will still need periodic table. Remember, you'll have the periodic table on your quiz. With these, you're going to go a lot faster pace. You guys should pick up on what we're talking about. By now, it shouldn't be too bad on it, okay? So start it off. Let's work this answer key. So first thing we got, number 1, is antimony tribromide. Key here has got a prefix, which tells me prefixes all the way throughout. Antimony is SB, and there's no prefix with it, which means there must be 1. And I have bromide, tries 3. So there's 1. Moving from there, let's go to number 2. Dinitrogen trioxide, got those prefixes again, spells it out for us. So N2O3. Got one a little bit more complicated. Phosphoric acid. Key is acid, so I know I have hydrogen in the beginning. There is no hydro prefix here, which means it is an oxyacid, so I'll look at the polyatomic it comes from. In this case, change it acid to 8, so you get phosphate. And phosphate is PO4 3 minus, so PO4 3 minus tells me I need 3 hydrogens. All right. Move number 4. Number 4 is hyponitrite. I do this by looking at, it's a polyatomic because of the ending of "ite," but I know I need to look at this based off the root, which would be nitrate, which is NO3 minus. I'm going hyponitrite, which means 2 fewer oxygens, so NO minus. Okay? Number 5, lithium oxide. This is Li plus. Oxide is just oxygen, which is 2 minus. Cross the charges. So Li2O. Hydroxide is a polyatomic, which is just OH negative. Okay? Like I said, guys, if this is going too fast for you, you need to go back to the other videos and work those. Okay? Moving on here, potassium sulfate. So potassium is K plus. Sulfate, that's a polyatomic, ends at 8, so SO4 2 negative, because that's the root. So I just jump to it. I cross these charges over. I'm just taking those numbers, remember that. So I have potassium, which is K, 2 comes from the sulfate, and then SO4, because I don't need multiples of it, I just need one of that sulfate. Alright? Moving on here, doing silicate. Silicate also is polyatomic, and it's the root ion, so I have its memory. So SiO3, 2 negative. Moving on to number 9, we have iron 2 fluoride. So iron 2, Fe2 plus. Fluoride is F negative. So that 2 comes over for the fluoride, 1 down for the iron. So we will have FeF2. This next one's a little bit of a trick problem. Calcium, most of you probably just went bam and said you were done. In that case, you are wrong, because that is calcium, but calcium as an ion is also calcium because of how we name the monatomics. So you also have to include the monatomic ion with it. Probably tricks you there, but it's good that I pointed out to you now instead of later. Okay? Move some stuff out of the way. Let's slide this on up. So let's go to number 11, mercury 2 silicate. Mercury 2 is Hg2 plus. Silicate is just like above. SiO3 2 minus. That's a 1-to-1 ratio, so it's just Hg SiO3. That is an S. Go to number 12. I have disulfur, so prefixes, which tells me that it's spelled out for me. So disulfur, so S, 2, fluoride, and DEC is 10. So S2F10. Then go here to the calcium hyponitrite. So calcium is a Ca2 plus hyponitrite. Okay, I'm going to have to go from the root on this, which is nitrate. Nitrate is NO3 minus. Hyponitrite, that's 2 fewer than the root, so it's NO minus. Do what we did before. Cross these guys over. And this is the key. This is a really good example here. We only have 1 calcium, so Ca. But that 2 from the calcium comes over for the hyponitrite. I need multiple hyponitrites, so I had to put this in parentheses. If you don't put it in parentheses, and you just put that 2 next to it, then it's like you're saying there's 2 oxygens, which would make that nitrite. So you need to make sure you get that. If you got questions about it, come see me. Number 14, iron 3 nitride. So iron 3 is Fe3 plus. Then I have the nitride, which comes from 15th column, so 3 negative. It's a 1-to-1 ratio, so it's just Fe N. Then we have francium fluoride, or francium, however you want to call it. Francium, so Fr plus because it comes from the first column. Fluoride, F negative, so it's just FrF. Go to the next one, nitrous acid. Acid. There's no hydro prefix, which means it's an oxyacid, not a binary, so it comes based off a polyatomic. In this, acid came from ite, so it's nitrite that I'm looking at. And nitrite is NO2 minus. If you need to, work it from the root of nitrate, that's fine. So I need a hydrogen first. Because it's an acid, then I have NO2. And I only need 1 hydrogen here because of this -1 charge. That's the key. Okay? Then we have barium perchlorate. Barium is Ba2 plus. Perchlorate, so that's 1 more oxygen than the root. Chlorate is ClO3 minus. So perchlorate is ClO4 minus. Take these charges, cross them over. And it's going to be like that one before, what was it, number 13. We're going to need parentheses on this. How do I know that? That 2 there for the barium comes over for the perchlorate, so I need multiple perchlorates. So it's Ba. I only need 1. Then I'm going to do the parentheses and put perchlorate inside the parentheses, close the parentheses, and put the 2 from the barium. Hopefully that makes sense. Number 18, carbonic acid. Carbonic acid. Okay, so in this, the key to it is acid, so hydrogen has to be first. Carbonic, there is no hydro at the beginning, which tells me this is not binary. So I'm going to be dealing with an oxyacid, comes from a polyatomic. I need to find the polyatomic. Carbonic acid. Ic acid comes from H, so carbonate, which is the root, so CO3 2 minus. So we're going to put CO3 here. And that 2 minus means I need 2 hydrogens. Start 2 hydrogen there. Hold on a second. Somebody go. What is these?
Okay.
Okay. Awesome. All right, so let's go to this number 19, last one on the first page. Lithium hydroxide. Lithium comes from the first column, so a plus charge. Hydroxide is a polyatomic, OH, and it has a -1 charge. It's a 1-to-1 ratio, so it's just LiOH. And that's it for the front. Now go to the back. We changed it up. The front was all about the names and going to the formulas. The back's all about these formulas, and then we're going to have to go to the names. Okay? So we'll keep working these. Let's keep it up. Let's go with number 20. Number 20, I count the number of elements I have present. There's 3, which means there's a polyatomic. I find the polyatomic. It's the NH4. I know that, first off, because I know my polyatomics. That's ammonium. And also because it's in parentheses. So ammonium bonded with oxygen. So in this, we're just going to name it like we would a normal ionic bond, but we're going to name the polyatomic instead of naming the monatomic ion. So ammonium oxide. We come down to 21. 21's a good little trick. O2, oxygen is a diatomic. In this case, it's naturally bonded to itself, so it just is oxygen. Then you go down one. We have HNO2. So I have hydrogen first, which means I'm dealing with an acid. Dead giveaway. Now I count. I have 3 elements. With those 3 elements being present, that tells me there's a polyatomic. So I'm dealing with an oxyacid and not a binary acid. So hydro will not be used in this. I need to find the polyatomic I normally am dealing with. I have nitrogen and oxygen, which comes from the nitrate family. And nitrate is NO3 minus. This is 1 less oxygen than the root, which means it's nitrite. So nitrite. And remember, we're making an acid. Take the name, remove the ending. Ite becomes us, O-U-S, acid. Number 23, LiOH. In this case, there's 3 elements, so there's a polyatomic here. Find it. It is the OH, that is hydroxide. And it's bonded with lithium, so it's like it's an ionic bond, so we just name it. First, we're going to name the cation. It's just the element name, so lithium. Hydroxide. Go to number 24. Number 24, I have iron. Iron is in the D block. So it is an ionic bond, but iron carries multiple different charges. Therefore, we must name it with a Roman numeral. So we will have iron, parentheses, with some charge, oxygen, so oxide. We have to find that charge there. So the charge on the oxide, we're going to look at the anion first to find the charge. So the charge on the oxide is -2. I have 3 of them, so I multiply it by 3, gives me -6. So +6 has to be the overall charge of the positive part. And I have 2 irons, so +6 divided by 2 is +3. So it's iron 3 oxide. Alright. Going to this next one. This next one's a really good, tricky one. If you get into a groove of something, then I probably caught you here. You count, there's 3 elements. So you know there's a polyatomic, you find it. It's the PO2. Phosphorus and oxygen, those are the phosphates. Phosphate, the root is PO4, 3 minus. This is 2 fewer oxygens. So this is hypophosphite. Then I look at my cation. My cation is chromium, number 24 off the periodic table. Chromium falls in the D block, so it carries multiple different charges. So, so we have to name it like we just did the one before. So chromium, and there will be some charge with this, hypophosphite. Chromium hypophosphite. Whenever you look at this to find the charge of the chromium, charge of the hypophosphite is -3. And I have one of those, so -3 means the overall positive charge has to be +3, and I only have one chromium, so that's a +3 charge. So chromium 3 hypophosphite. Moving to the next one is a pretty good one, just like 25. With this, 3 elements present, find your polyatomic. So NO4, that's one more oxygen than nitrate, so that's per nitrate. Then I look at the one before it. My cation is cesium, comes from the first column, has a fixed charge, so we just named the monatomic ion, cesium per nitrate. (27) I have 2 elements present with a charge, which tells me it's just a polyatomic. In this case, this polyatomic is one of the roots, so it's just borate. (28) is one you guys will normally just roll right off. It's an ionic bond between sodium and chlorine. So we name the monatomic, so sodium, and then chloride. I know I'm going faster on this one, but at this point you should be picking this up by now. If you're not, come see me, okay? We're literally at the last minute of this, guys. We're getting ready to quiz. It's game time. Number 29, N2. N2, that is a diatomic. So it's nitrogen. Number 30, N3F6. Both nitrogen and fluorine are nonmetals, so that means covalent bonds, so use prefixes. I have 3 for the first one, so try nitrogen. Hexa for the 6, fluoride. Go to number 31, we have P4O10. Phosphorus and oxygen are nonmetals, so we're yet again looking at a covalent bond. Use prefixes. Tetra for the first one, so tetraphosphorus. Dec oxide. So tetraphosphorus, dec oxide. Okay? Number 32, IO3. I have 2 elements present, but no charge, so it's not a polyatomic. We look at the bond in it. We have iodine and oxygen. Sorry, my wife texted me there. We have iodine and oxygen. So iodine and oxygen, they are both nonmetals. These nonmetals, nonmetals bonding together is covalent bond. Therefore, we're dealing with using prefixes. In this case, have iodine, but the first one, there is no prefix needed because it's only one. And when it's only one, you don't use a prefix. So iodine, or iodine, however you want to say it. Trioxide. Alright? O2, 2 minus, it's one of those special cases. It is a polyatomic. So in this, you just have to know the polyatomics. This is peroxide. Number 34. You count it up, and there's 4 elements present. 4 elements present tells you one thing. there's two polyatomics here. Find the two polyatomics. There's one, there's the other one. So you literally just name the polyatomics.
I need the following students to report to the Digital Learning Center. Madison Atwell, Kevin Akers, Johnny Brown, Mackie Brown, Deanna Belcher.
So in this, it's ammonium.
Brown, Alyssa Bailey, Natalie Booth, Katie Brown,
Cyanide.
Madison Blankenship,
Make sure I
Leslie
spell this
Browning,
right.
Alex Bailey, Madison Brown, Kaylee Brown,
All right.
Leslie Bailey, Jennifer
35.
Kristen Blankenship, Hunter Blankenship, Mackenzie
Number
Brown.
35, SiO2, there's two elements present but no charge, so we look at the bonds. In this case, silicon and oxygen both are nonmetals. Two nonmetals mean covalent bond, means use prefixes. Silicon, I didn't put a prefix with that because there is no need for it, where it's one, okay? Remember that first element, we only use prefixes if it's something besides mono. Silicon, 2, so dioxide. Number 36, it's RB and I, so rubidium and iodine. There's two, there's no charge. Look at the bond, bond is ionic because rubidium comes from the first column, and iodine comes from the 17th column. So a metal with a non-metal, so we name the monatomic ions. So Rb is rubidium, and I is iodide. Okay? 37. 37 is sulfur and fluorine. There's two elements and no charge, which means it's down to the bond. Sulfur and fluorine both are nonmetals, so covalent, so use prefixes. So it should just be sulfur hexafluoride. Number 38, NH3. Okay, then it's NH3. It has a common name that I'm not requiring you to know. Somebody in class actually named it with a common name, so I would give you credit for it if you called this ammonia. Not ammonium, ammonia. A-M-M-O-N-I-A. I would give you credit for that, but just look at it this way. It's nitrogen and hydrogen. There's no charge. Since there is no charge there, you look at the bond, they're both nonmetals, so they're covalent, so just name it based off of that. So nitrogen trihydride. Okay? Last one, number 39. N2O3, we look, there's no charge, so this is not a polyatomic because there's only two elements, so then we look at the bond. Nitrogen and oxygen both are both nonmetals, so we're dealing with a covalent bond. So we have a 2 in this case, so we have to use a prefix. Dinitrogen trioxide. Alright? So guys, you now have, after this video is uploaded, you now have all keys for all those nomenclature sheets we've done. Please, 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 please study. You need to study. This is not an easy concept. All of this mixed together, guys, there's a lot on here, so please study. If you have questions, come ask me, okay? You got tomorrow, you come ask me. Monday will be the quiz. It is game time.